started recording. Good, need to remember to do that. Now, coming back to our geomean, different kinds of means, simple mean and geometric mean. Okay, so just to make sure we understand everything. Oh, I'm not sharing, right? Let's go back and start sharing. Entire screen, yes. Okay, so we have negative 4% geomean. On average, every year we are losing 4%, right? Let's see how much money we have by the end of 2 years. We lost about $80 from $1,000 to $922. So $80 is about 8%, so it all makes sense. Every year we're losing about 4%. In 2 years altogether we lost around $80, about 8%. That's because it's 2 years, 4% loss each. That makes sense. One question to you guys. This looks like exact 4%. Looks like an exact 4%, I don't know. So, yeah, looks like it's pretty exact. This is exactly 2 years, so I'm gonna lose 8%, right? 4% and 4%, I think it's 8%. So if you lose 8% out of $1,000, is it like 920 exactly? Is it? Tell me. Why, the question is, why I don't see 920 exactly here? The person who will answer that question first will get, let's say, another 5 points bonus for the midterm next week. Any ideas?
Professor?
Yeah.
I guess, I don't know, but I guess in the second year it's increased. So if like in like 2 years, like the return is decreasing like 4% and 4%, it's gonna be like exactly like 8%, but like in the first year it's decreased like a several percent, and like second year it's increased. So I think that's why it's not like an exactly number. It's not.
Good thinking. Good thinking. Good thinking.
I don't know
But we
how
need more thinking.
can
This is not
I.
exactly. Actually, I can show you that if we lose 4% and then 4%, we still have the same number. One more attempt, anyone? Ricky, so if I understand your answer, you are saying it's because instead of -4, we just have minus and then plus. Because of a bit of a plus, that's why a bit of a discrepancy, right?
Yeah, that's kind of.
Good thinking. Not really. Look, okay, I guess not taking any more answers because it's getting easy. If we put 0.04 here, 0.04 here is the same number. Okay, you know why? Because in the second year I'm losing 4% of a smaller number, so I'm losing a little less. You understand, Ricky?
Yes.
Yeah. So if I like show it on a timeline, right? Let's say this is time, right? And I start with some amount of money, let's say 1,000, right? And every year I lose 4%. Every year I lose 4% of the previous amount. I don't lose 4% of the original amount. If I lose every year 4% of the original amount, like the straight line depreciation, right? It's going to be a straight line. But if I lose 4% of the previous year's number every year, it's going to be an asymptote like this, right? Does that make sense? Right? So I think it's pretty interesting. Okay, so let's continue. Where do we want to continue? Yes, with this example, bigger example with geomean. So let's do the geomean again for a more interesting example. First thing you want to do is 1 plus, add this column that equals 1 plus the returns. Hit enter and copy. So these are the returns plus 1. Okay. Then we take a product of all of those into the power of inverse number of years, right? So equals this times 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 this times. Okay, back up a little. This times this times this times this. Okay, then take that into the power of 1 over the number of years. In this case, this is 13. Okay, and then equals this minus 1. So on average here, actually I'm earning something like 4.8%. 4.8%. Although the simple average incorrectly overestimates, says that I earn about 5.6%. So usually, okay, simple average is always, not always, usually simple average is higher than geomean. There is only one case where simple average is going to be the same as geomean, okay? Let's say, for example, we have years here and the returns. If the returns are all the same in every year, only then and then simple mean and geomean will be the same. In this case, they will be both 2%. Okay. If the returns are different every year, even in this case, the average is still 2%. Simple average is still 2%. Already geomean will be smaller than simple mean. So usually geomean is smaller than simple mean. Usually simple mean overestimates your earnings, okay, your returns. There is only one case when those are the same. That's when all returns every year are the same. So let's leave it here as a reminder, right? Okay, so this is geomean, geometric mean. Next reminder over here for me, how do we calculate geomean with Excel? There is actually an Excel formula, but it's a little bit kind of strange. Remember the geomean formula, right? Geometric mean, root of the number of years of all the 1 plus r's, right? Number of years, and then minus 1 outside this root, right? So, like, if you look at some textbooks, it's kind of a little bit confusing kind of. Some textbooks, they kind of forget about this minus 1. They forget about it. Same as Excel. Just strange how Excel is programmed. So if you try to calculate geomean with Excel, equals geomean, there is a formula, geomean, open the brackets. First, let's try to just give it the returns that I have every year. It doesn't work because it doesn't take negative numbers. So you need to make this column anyway. Even if you are trying to calculate geomean using Excel formulas, you still need this column, 1 plus. So again, equals geomean, open the brackets. We're gonna give it this 1 pluses, because this Excel formula doesn't work with negative numbers. Hit enter, and you see it gives us 1.4.6%. So the geomean formula that is built into Excel forgets to subtract 1. So we need to do that by hand. Okay, so there's that. Is this here done? Okay. And just a reminder, remember to subtract 1 by hand, even with Excel formula. Okay, so far so good. Any questions on how do we calculate geomean? Or geometric mean, geometric average? It's this part of the lecture. This part of the lecture. Any questions? Okay, seems okay then. Now, let's see what are my reminders. Oh yeah, risk premium. Risk premium. What is the risk premium? Okay, so let's say you have been investing into the stock market with these returns, right? So your average is about 4.8% return. Alternatively, somebody could have been investing into short-term government bonds. So let's say these are the returns of investing into short-term government bonds. Let's calculate the average. Just a simple average is fine. For example, because I'm just going to use it as a quick example, right? 3%, let's say 3%, right? So let's say investing into stocks, your return is, let's say, about 4.8%, right? Investing into short-term government bonds, which finance theory says supposedly have no risk, although if, I don't know, if there's a war tomorrow, the country disappears, then the government will not be able to pay you back, but it's not very likely. So we just suppose in finance there is no risk with short-term government bonds, okay? So with short-term government bonds, let's say you're earning around 3%. So over here, right, when you invest into stocks, your total returns are about 4.8%. That's higher than investing into short-term government bonds because you have to take on risk, right? But even if you did not take on risk, you still would get some return. You would get around 3%, right? So you get extra because you take on risk. And this extra has a name, which is risk premium. You have an additional return because you are taking risk. How do we calculate this additional return for taking risk? By looking at the difference. Even if you didn't take any risk, you still would get a 3% return. You get more than that, an additional 1.8% because you take risk. Okay? So in this case, risk premium is 4.8% minus 3%. Just copy this and get rid of the, get rid of the apostrophe at the beginning. That's a 1.8% additional return because you have risk. That's risk premium. Alternatively, if let's say you were investing into small firms, because they're small compared to regular stock market, maybe the returns are higher, but the risks are also higher. So let's say the returns are about 8.2%. Clearly, the risk premium of investing into small firms is higher. Again, how do we calculate the risk premium? This risk premium is stock market. Okay, here the risk premium of investing into small firms, right? Let's make some space. Is this 2.8%? I'm sorry, 8.2% minus the risk-free rate of return of 3%. So your answer is going to be 5.2%. Risk premium is higher for additional level of risk with small firms. Okay, so that's the risk premium. We always calculate the risk premium by subtracting the returns on no risk investment. And in finance, we suppose that short-term government bonds have no risk investment. Okay. So far so good? Any questions? Okay, and next, my reminder over here is how do we calculate the amount of money that you will have by the end of 2022 throughout all of these 13 years of investment. Let's say, for example, you start with $10,000. $10,000. How much money will you have by the end of 2022 years if these are your returns for every year? Again, you still need this column, 1 plus the returns column. You still need this 1 plus the returns column. The answer is going to be equal the original investment, which is $10,000 in this case, multiplied by all of this 1 plus the returns. Multiply, 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 which gives you $18,304. $18,304. There's also another way to calculate this same number, because geomean correctly says how much is your average return per year, right? So another way to calculate the same number is taking the geomean and multiplying it by 13 into the power of 13 years, because you earn this 13 times, right? So original investment 10,000 times 1 plus the geomean, so that's 1.0. I'm just gonna do, so I don't have any approximations. I'll just do 1 plus this exact number here into the power, somebody's coming, into the power of number of years, which is 13 in this case, and bam, we have exactly the same number. So here are the two ways of calculating the amount of money by the end of investment period. I'll give you the formulas. These are just reminders. I can erase them now. Reminders for myself, what I wanted to tell you about. Okay, there's a formula. There's a formula, and there's the formula. There. Okay, Control S. So that's how we calculate the amount of money that the investments will grow into by the end of the investment period. In this case, 13 years. So far so good. Any questions? And the last subtopic here is, so we've been talking about return for quite a while. Now let's talk about risk. Last subtopic is risk visualization over here. Okay. If you imagine returns on the horizontal axis over here, anywhere from negative 50% to positive 60%, and put the years onto this horizontal axis according to the returns people enjoyed. For example, in 2002, that is the year of the dot-com bust, dot-com bubble. The stock market dropped by around 30%. For example, in 2008, where's 2008? 2007, they don't show 2008 here. Anyway, the stock market in 2007 was starting to decline, and then in 2008, 2009, during the global financial market, stock markets dropped by around 50%. Right? There's 2008, by around 40%. Right? So, if you just imagine these returns on the horizontal axis and place the years onto this horizontal axis according to these returns, this will give you some sort of visualization for the risk. Usually, on average, we have returns anywhere between 10 to 20%, but sometimes the actual return can range anywhere from negative 50% to positive 60%. Another way to represent this same visualization is using this probability distribution, right? And this particular probability distribution is normal distribution. We talked about normal distribution. Here it is. We talked about normal distribution in our statistics class. For you guys, that was so that would be only 2 semesters ago, 1 year ago, right? Normal distribution, as we mentioned, is the most common distribution in nature, right? Including the stock market returns, right? And it's such that if you step away by 1 standard deviation away from the mean, you will include 68% of all the variations. Or if you step away by two standard deviations away from the mean, you will include 95% of all the variations. Or you will include 95% of all the observations. And if you step away by 3 standard deviations away from the mean, you will include 99.7%. More than 99%, actually 99.7% of all the observations. So what is this standard deviation? Actually, it's a measure for risk. There are a couple of measures for risk: variance and standard deviation. Again, those both should be somewhat familiar for you from your statistics classes 2 semesters ago, 1 year ago. So hopefully the rest of this lecture is relatively easy. Now we are looking at measures for risk. There are 2 measures for risk: variance and standard deviation. So let's see, how do we calculate variance and standard deviation? Okay. So here are the steps. First, we need to have the average return. Okay. First, we need to have the average return. And I think we can just use a simple average here. Okay. Then we calculate the difference from average return. That's the actual return minus the average return. Sometimes these differences are positive, sometimes these differences are negative. Okay. The reason I'm looking at these differences, oh, I see, I forgot to fix this reference. Hit F4. Okay. So as you see, these differences, sometimes they're positive, sometimes they're negative. The reason I'm looking at this difference is because I want to add them up. The formula for the standard deviation, where is it? Is it not shown here? Oh, it is here. The formula for variance and standard deviation involves adding up the differences between the actual returns every year and simple average returns. So we need to add them up. You see we have a summation here. But if I add up all the positive and negative numbers, they're going to kill each other. They're going to cancel each other, and I'm going to lose information. So for that reason, I take a power of 2 first. First, I take a power of 2 so that everything becomes positive. So let's say difference squared, like this, equals this into the power of, let's say, 2. Okay, like that. Good. Then I add them up. Like this. Bum. Wait, we don't need this. And then I divide by number of years minus 1. Then I divide everything by number of years minus 1. So equals this, divide by 12, because we have 13 years in this example. Okay. That gives me the variance. Variance in all of these returns is like plus minus 1.8%. So equals this. There's actually another way to calculate variance using Excel. Just simply hit equals var.s. There are different variances, but in this case we're looking at a sample. We talked about the difference between sample and population during your statistics classes. Okay, so var.s, we're looking at the sample, open the brackets, give it all the returns. There it is, same numbers here. Okay. Do like this, that will be the same number here. And again, as you know from your statistics classes, standard deviation is a square root of variance. Here, standard deviation is a square root of variance. So simply equals SQRT of this number. There it is. Equals SQRT of this number, or equals stdev using Excel, stdev.s. Again, this is sample, stdev.s, give it all the returns, bam, these are the same numbers. Okay, so these are the measures for risk. What have we done today? Basically, we're talking about what we can learn from financial history, and what we can learn is that everything is risky. Everything is risky. To get any reward, to get any return, you gotta take on risk. And there is also additional relationship. The more risk, the more potential return. But because there is risk, it's also possible to lose everything. And after that, what we learned is that we learned how to measure returns, right? How to measure returns, different names for the returns, as well as how to measure the averages for those returns, whether simple or geometric averages. And talking about risk, we also learned how to measure risk, variance and standard deviation, somewhat similar to your statistics classes. What's not similar to your statistics classes, we haven't mentioned before, is of course the risk premium. That's something completely new. Okay, a bit of a summary for today. Questions?
Professor,
Uh-huh.
will you put the Excel file on Moodle?
Okay, Control S, Excel file, okay, saved. I'll put it on Moodle.
Professor, did you record it?
Yes, I recorded. Oh, good, you reminded me. I gotta take the attendance. So, in the next 30 seconds, type in your student ID. Am I recording? Let's check that. Yeah, I'm recording, right? Okay. Ten more seconds. Type in your student ID for attendance. Attendance is graded. Very little grades for that. Forums have more grades. Remember to share your opinion in the forum for last week. Okay, so for the video recording, let me scroll through the attendance IDs. Okay, I think it's on record now. That's okay. Right, before I forget, let's put that Excel file there. Now is week 8, financial history lesson.
Excuse me, Professor?
Yes, yeah.
Did you prepare as practice test for midterm?
You have your tests every week. I think it's generally enough. You have all these Excel files. So no need for an additional practice set of questions for the midterm, because otherwise the midterm becomes extremely easy.
Thank you.
So you have tests every week, questions are relatively similar, and the Excel file from today is already on Moodle. Okay, so over there you have all the formulas that I've used as well, so should be relatively easy already. I don't want to make it too easy. I don't want to make it into kind of a joke exam. It's already relatively easy anyway. More questions? The Excel file is already on Moodle. So,
Professor?
Yep.
I want to ask if text or quiz week 6 will include in our midterm exam or not?
Quiz week 6 will include the
Yeah,
midterm exam?
or
No,
not,
midterm exam is
because
separate. And the quiz for week 6, let's share the screen. I don't understand the question. So let's share the screen. Let's go to Moodle.
is it
Here's week 6. And here's the test. And the midterm exam is in week 9. I don't understand the question.
because we didn't get the grade from week C until now.
The grades for the test, you mean? You mean you don't know your grades for the test?
Our result from week C.
Ah, I see. You want the answers for the tests? Is that right?
Professor, can you please say again?
You want the answers for the tests? Is that right?
No,
The
I
results.
think the test, you just haven't checked it, I think.
That's right. Yes. Yeah, I haven't checked the results for tests, but the grades are separate. So I think I'm still sharing, right? So grades. I haven't checked the tests yet, so they're all empty over here. For tests, you have separate grades. You have 30 points for the tests, and you have 30 points separately for the midterm exam. So yes, I didn't check and didn't announce all of your grades up to tests 7 today, right? But beyond those test grades, the midterm exam grades will be separate, if I understand the question correctly.
No, because our our test six is, I think it's making a chart,
Ah,
like a
chart. That's right.
graphic,
Yes, sensitivity and
but we haven't get the grade
yes,
from that.
sensitivity and scenario charts, sensitivity charts. Yes, sensitivity charts. That's right.
Yeah. So I mean, like, if our meeting exam will include in like making a chart or something, because we didn't know if our chart is correct or not.
Oh, I see. I see. You're asking if the midterm exams will include making a chart. Okay, the midterm exams will not include making a chart, but the midterm exams will very likely include questions about sensitivity. So for example, let's say, okay, let me look at you guys instead of Moodle. Where is it? Here, stop sharing. Okay, so the question is whether midterm exams will include questions where you have to create your own charts. The answer is no, the midterm exam will not have a question where you have to make your own charts. But there will be rather similar questions to test 6, to the text 6. For example, let's say you have all the data on the operations of the company, and let's say you have a question like, if the projected sales have a sensitivity of, I don't know, plus minus 15%, right? How much does that affect NPV? Okay, so minus 15%, that will mean that NPV is this much. Plus 15%, that means NPV is this much. Or let's say, for example, because it's pro forma statements, we don't know the future. If, let's say, the fixed costs into the future are only expectation, and the actual reality can be with a sensitivity of plus minus 20%, how is that going to affect NPV? Right? If it's minus 20% for costs, of course NPV is going to be higher. How much? If it's plus 20% for fixed costs, of course NPV is going to be lower. How much? So it's all going to be based on numbers. Same topics on sensitivity and scenarios, but you will not have to actually create your own charts. Okay?
So Professor, can you like teach us the taxes, like the question from test 6?
Test 6, okay.
Because we are not sure about our answer, so I don't know if our number is
Right.
correct or not. Because we only like submit our graphics, right? But
I see.
our
Okay, sure, yes.
I mean like the number of the graphic we don't know that.
Let's see. Sharing, I think. Okay, just opened somebody's test. Okay, just by chance turned out to be Maureen. So we have some information here. A 3-year project, required return 12%. Let's open Excel. So a 3-year project, required return 12%. Equipment cost 40,000. Yeah, 40,000. Straight line depreciation to 10,000 book value. So over time, book value goes down from 40, not to 0, but in this case down to 10 in 3 years. 1, 2, 3 years. So that tells me that depreciation is going to be, in 3 years we went from 40 to 10, right? So every year 10,000. Does it make sense? I think it does. Okay, salvage value 5,000. Okay, so we're gonna sell it. That's of course before tax salvage value. It's gonna be 5,000. We're gonna sell it for 5,000. Project requires 2,000 net working capital, and then 20% of sales. Okay, net working capital at the beginning is gonna be 2,000, and then later net working capital is going to be 20% of sales. Sell these many for the next 3 years, right? So 220, 300, 320. Okay, that's sales units. Sales price is expected to be 150 in each. Okay, 150 price. And variable cost, the cost of each unit, 40. Okay, fixed cost 5,000. Interest expense 8,000. Interest expense 8,000. Tax rate 30%. Okay, so we need to make up our pro forma income statement. Revenue is going to be equal. Okay, let's have quantities here. There's going to be 220. That's quantity. Let's have price is the same, so I'm not going to change it every year. 300, 320. Revenue is going to be equal to this times the price, which is 150. Okay, so there's the revenue. Minus all the costs. Let's start with the variable costs, which is equal to the quantity times 40, the variable cost of 40 every year. For the exam, the price and variable cost might also change every year. Okay, right. All the other costs, what else do we have? We have depreciation, for example. We have fixed cost. Let's put fixed cost here. That's 5,000, yes. Okay, depreciation. These numbers I don't need anymore. Depreciation 10,000 every year. What else do we have? We have interest expense. Okay, 8,000. Okay, I think that's all the costs that I see. All right, so we can calculate EBIT, earnings before interest and tax, equals revenue minus all the costs. We can calculate EBT, earnings before tax, equals EBIT minus the interest expense. The tax payment is 30% of EBT, equals 30% of EBT. Okay, and we have our profit or net income, EBT minus tax payment. All right. Is that correct? That's much bigger, that's much smaller. Are those correct numbers? Okay. Seems to be correct. I guess that's because quantities increase a lot from 220 to 300, so this increases. Okay, seems to be correct. Right, so that's years, of course. 1, 2, 3. Okay, so remember we need 3 kinds of cash flows, right? Operating cash flow from long-term capital, that's net capital spending, and cash flow from short-term capital, that's changes in net working capital. Okay, so years 0, 1, 2, 3. Operating cash flow at the year 0 is 0. At the end of year 1, operating cash flow is equal to EBIT plus depreciation minus tax. Okay, same for the other years like this. Net capital spending. At the beginning, okay, at the beginning, we spend 40,000 to buy the equipment. Okay, and at the end we sell it for 5,000. At the end we sell it for 5,000, but we gotta pay tax on that, or we can claim tax back if it's below book value. Book value at the end is 10,000. I didn't write it down in the Excel file, but it says here, book value 10,000 at the end of the project life. We only sell it for 5,000, so we claim the tax back. So salvage value after tax, right, is the money that we get from the seller, 5,000 times the money we get from the seller minus the book value, and that multiplied, the difference multiplied by plus over here, plus. I mean minus. This difference multiplied by the tax rate, in this case 30%, yes? Okay. So we get a tax refund of 30% of the difference, okay? 1,500, 30% of 5,000, 1,500, plus what the seller gives us, that's 5,000, altogether 6,500. Makes sense. I might have made a mistake, but it doesn't look like I make a mistake because everything is kind of matches with your expectations. Changes in net working capital. At the beginning we put in, where is it? 2,000. Every year after that, net working capital should be 20% of sales. This is sales revenue. So changes is going to be 20% of the sales revenue minus what we already had before, right? That will be the change, an addition that we need to put in. Okay, so like that. But at the end of the year, we take everything back. Okay, at the end of the year, we take everything back. So 20% of this amount. Okay, let's have net working capital, not only the changes, but the full amount of net working capital. 2,000, this will be 6,600. Look, 20% of this amount is 6,600, of course. So at the end of that year is going to be 9,000, and at the end of year 3 we're going to take out everything that there was. All the 9,000 is going to come out back into my pocket. That's going to be negative 9,000. I mean, net working capital at the end of this year will be 0, but over here is going to be negative 9,000. The changes, because I take everything back to my pocket, the company is closed down. Okay, so there. Another way to calculate this number is equals this plus this plus this. This formula is not correct. It's 20%, yes, 20% minus this and minus this, yes. No. Okay. That's why it's good to have the line for net working capital. The actual net working capital is 20% of revenue. Okay, 20% of revenue. So the changes, I'm gonna redo the changes here, equals this minus the previous number. There. Previous number was too high, 4,400. Actually, it's 2,000 9,400. The increase from 6,600 to 9,000. Okay. And over here, the change, all of the 9,000 comes back to my pocket. That's negative 9,000. Okay. So these are the changes in net working capital. And lastly, the cash flow from assets. That's what we need to look at. That's equal to operating cash flow minus net capital spending minus changes in net working capital. So it makes sense. At the beginning, we don't earn any money. We invest 40,000 into equipment and invest 2,000 into short-term assets. We just lost 42,000. Okay, stretch it. These are the cash flows from the business. Then we can, what do we need to calculate? Okay, tax rate. Okay, for sensitivity analysis, assume sales might change up or down by 20% of the planned units sold. Okay. Make a chart with the average total units sold for the whole project. On the x-axis, NPV of the NPV on the y-axis. Units on the x-axis, NPV on the y-axis. Okay, good. So this is the base case. The chart is going to be on the y-axis. I'll have NPV. NPV on the x-axis. I'll have on the x-axis. I'll have units. Minus 20%, base case, and plus 20%. Let's put it in percentages. Plus 20%. Okay, like this. So base case, we already have NPV, we don't have yet NPV, so equals NPV, open the brackets. The rate is 12% over here. And the values starting from year 1. Add the original by hand. Okay, where's the number? There. So for NPV, for year 0, we'll put the number at 9,000, which just equals this. Okay. Make it larger. If everything is 20% less, okay, just multiply these numbers by 0.8 equals 0.8. This formula is going to change as well. Let me just put it as a number 9401, like this, let's say. Now I'm going to change everything, bring it down by 80%. It's going to be equal 0.8 times this number. Equal 0.8 times this number. And equals 0.8 times this number. Okay, so we see NPV drops down to, let's say, $747, let's say. I'll just keep it round. And if everything is much higher by 20%, so I'll multiply everything by 1.2 instead. Multiply everything by 1.2 instead. And multiply everything by 1.2 instead. NPV rises to $18,055. $18,055. This should be your chart, something like this. Okay, so you can do it like that. Say units. Okay, and let's say NPV. So we have, let's say, minus 20%, 0, or maybe like units changed. Minus 20%, 0, and let's say plus 20%, like this. NPV numbers, say 747, 9401, 18055, like this. You can select all of these, insert, chart, there's a chart. Okay. Questions?
Professor, sorry, the net capital spending in year 3, is it not going to be like minus 6,500 because of the gain?
You're right. Yes. Yes. Thank you.
Okay.
Am I sharing? I'm not sharing. I was already looking at that, but I forgot to share. You are right. Thank you very much. Because I'm getting it back. I'm getting it back. Oh my God. Easy to make a mistake, you see. So we multiply everything by -1, let's say. Times -1. You're absolutely right. Yes. Thank you. So NPV numbers change here. Of course, NPV numbers change, but basically I explained how to make this chart. Sensitivity chart. Thank you. You're absolutely right. Any other questions?
Can you send a file into the Moodle because it's fast for me to look at it.
Say it again.
Can you upload the file to the Moodle, please?
This sensitivity chart file.
Yeah,
It has a
like
mistake
the file
because
you
I didn't correct these numbers. Okay, let's correct these numbers.
Okay.
Just
And
1 second.
I just wonder if you can extend the time for the test today because we also have a class after this and we also want to have lunch too.
I see. Yes, yes, yes.
Yeah, I hope
Let's do that before I forget. So, okay. Test today, yes? Okay. Test today. Okay, let's make it...
And Professor, I still have one question.
Yep, yep.
Can you explain again
Uh-huh.
the change in net working capital for the last year?
Yep, okay.
Why we should like type -9,000?
Okay, so test today until 6 p.m. Now, start sharing that file. Okay, first, before I answer your question, let's fix the mistakes, right? So NPV changes. This is the best case that goes up to 27,309, let's say. So the chart here changes automatically. Then the base, not the base case, let's say 0.8. The worst case, let's do that first. Okay, so the worst case here is actually 10,000, let's say, 10,000. And the base case, just delete all of these. Just delete all of these. The base case is 18,654, 18,654. Okay, this is fixed. There it is. Right, save. Sensitivity. Okay, now to your question, for the changes in net working capital for the last year of the project, it's kind of special case. Whatever happened to the net working capital before that, okay, all of the net working capital by the end of the previous year, you're going to take back when the project finishes, because we don't have any depreciation for net working capital. So assume the net working capital does not diminish by usage. Easy example for that is, imagine net working capital is the coins change in your cash registry machine, in your till this machine, right? So if you close down your business, the tea shop, you're gonna pour all of those coins back into your pocket. So whatever happens through the networking capital throughout the years, all of the networking capital that you have in the previous year before last, you're gonna just take it back. So for the last year, for the changes in networking capital, you look at how much networking capital you have before the last year, and then put a negative number for the last year, because you just take everything back at the end of the project's life. Okay? I think that answers the question. And
Okay, I got it.
yep.
Thank you,
And
Professor.
then last thing before I forget is to put this file there. Yes, save it. I think it's saved. This we don't need anymore. Somebody's drawing here. Oh, I don't know what is that. 1, 2, 3. It doesn't look nice there. Okay. Okay, where is that file? Here. Put it here. That's your answer to test 6 in week 7. Okay. Right, coming back. Stop presenting. Last chance for any last questions. Still recording, that's good. Okay, I think that's all. Ricky looks tired, he's already lying down.
No.
Well, I'm tired already. I'm gonna go have lunch. Okay, guys. Thank you. Bye bye.
Thank you.